Wireless network. Stop here, for we have covered network attacks only on wired networks. What if it is a wireless network? What is a wireless network? A network that uses radio waves to establish communication between two or more devices within a limited coverage area is known as a wireless network. A wireless local area network is similar to that of a general radio frequency used for broadcasting channels, such as amplitude modulation, frequency modulation, and medium wave, which have a defined bandwidth under which radio stations operate. These contain a set of specifications called as IEEE 801.11 to accomplish communication over air. The general frequency spectrum for this standard lies at 2.4 GHz, 3.6 GHz, and 5 GHz, wherein the 3.6 GHz spectrum is specifically only used in the USA, while the 2.4 and 5 GHz spectrum are the commonly used Wi-Fi spectrum. The 2.4 GHz spectrum has 14 channels in its spectrum, each covering a distance of 22 MHz with a distance of a 5 MHz gap in between them. This spectrum operates at a 1 or 2 Mbps data rate as well as at 54 Mbps and is termed the 802.11 and 802.11g standard respectively. The 5 GHz spectrum has 24 channels in its spectrum, each covering a distance of 20 MHz. This spectrum operates at a data rate of 11 Mbps as well as a 54 Mbps and is termed the 802.11b and 802.11a standard respectively. Having seen how the standards evolve, let us step into wireless cracking. Before getting into cracking wireless networks, it is necessary to know how wireless networks work. Wireless networks work on radio frequency, which is nothing but electromagnetic fields that are taken as input by an antenna. Radio frequency is mostly used for wireless broadcasting and communications. A PC with a network adapter and an amplifier or antenna is capable of catching wireless signals. Some PCs come with built-in network adapters, whereas some need an external network adapter to get connected to a wireless network. Laptops have built-in wireless network adapters. A network that is communicating via wireless radio frequency needs a device that should be able to transmit and receive radio signals, and this device is the wireless router, which is also called the access point, or AP, for the devices communicating through it. The set of wireless devices communicating through an AP together is called a Basic Service Set, or BSS, and this forms the wireless LAN. The access point has its own MAC address for unique identification, which is called the BSSID, or Basic Service Set Identification. This AP, or the access point, is christened with the name of a 1 to 32 byte string called the Service Set Identifier, or SSID. The access point is identified only by this name by the clients. Thus, these are the basic things one must know before getting into wireless or wireless. The communication happens based on the OSI model. Let us first get a glimpse of the attacks pertaining to wireless based on the OSI model. Physical layer. This is the first layer in the OSI model, and the attacks pertaining to this layer can be performed upon gaining a direct access to the network. Physical layer attacks include the following: radio frequency interference, and AP removal. Data link layer. The next layer is the data link layer. As discussed earlier, this works based on the MAC address, and the attack vectors pertaining to this layer include the following: war driving, finding hidden hotspot, web cracking, packet injection, cafe latte, Herta, and Corex chop chop, WPA cracking, WPA2 cracking, and rogue AP. Physical layer. The very first layer, the physical layer, here in wireless transmission, uses access points unlike wired transmissions that use cables. The targeted attacks include radio frequency jamming and AP removal. Radio frequency jamming. A direct approach to a physical network allows an intruder to perform radio frequency jamming. As already seen, access points are the ones that emit the radio signals to connect the systems to the wireless network. When the signals, that is, the radio frequency, are intentionally interfered with, making it unavailable to the clients to get connected, it is called radio frequency interference or radio frequency jamming. This can be accomplished by pinning a radio frequency jamming device on the network. A jamming device works on the same radio frequency of the access point. It sends out signals of high power that matches the radio frequency of the access point, which at one point of time starts colliding, thus overwhelming the signals with noise and getting nullified. This now disrupts the communication between the client and the access point. It is also called a physical layer DOS. AP removal. AP removal is one attack that is equal to vandalizing, which needs physical access to the device. Removing or destroying the device would make it unavailable to service its clients. Having seen the ways in which these attack vectors harm a network, both radio frequency jamming and AP removal can be accomplished to disrupt the availability of the CIA triad.
Data link layer. The next layer is the data link layer. The data link layer, as discussed earlier, works based on the MAC address, and the attack vectors pertaining to this layer include war driving, finding hidden hotspot, WEP cracking, packet injection, cafe latte, hurt, Corix chop chop, WPA cracking, WPA2 cracking. To land upon at the different hotspots available and to check the vulnerabilities in them to launch an attack, war driving lends a helping hand. War driving. Having derived its name from the film War Games, where the concept of war dialing was portrayed. War dialing is nothing but dialing every phone number in a specific sequence in search of modems. It is also the search for Wi-Fi networks in a moving vehicle. How was it done? In the earlier days, catenna that were unidirectional signal capturing devices used along with a GPS locator to go for a war driving, but this would capture signals only in a single direction. This led to using omnidirectional antenna to capture Wi-Fi signals. When a Wi-Fi network is found, the status of the wireless network was stated by drawing symbols that would indicate the presence of the Wi-Fi hotspots and their status, such as open, closed, restricted access, pay for access, MAC filtered, Wi-Fi with WPA, Wi-Fi with closed SSID, Wi-Fi honeypot. This method of drawing symbols to indicate the presence of a Wi-Fi network around is called war chalking. Over time, instead of marking the status of the Wi-Fi networks at the corresponding area, people began generating raw files that can later be opened with mapping software, which has made things easier. This can be done by using easily available tools such as NetStumbler, wherein there is no GPS built in with the tool, but it gives an output as a KML, that is, keyhole markup language file, that can be opened with mapping software. To make things easier and simpler, a tool such as VisTumbler, specially designed for Windows Vista and higher versions, that has a built-in GPS and maps the location easily, is being used now. When a person wants to know the Wi-Fi networks available in a particular area, they can just open the raw file uploaded on the web using a mapping software even in his handheld device and enumerate the networks available. When the attacker walks with the Wi-Fi enabled device and logger software over a geographic area, it is called war walking, and when the same is done while flying, it is termed as war flying. From the results of war driving, one may see that there are different Wi-Fi hotspots listed. But out of it all, look at this. This wireless LAN's length is not revealed. That is, the name of the SSID is hidden. There exists a Wi-Fi security agenda stating, "Don't broadcast your SSID." And people tend to believe in this and restrict their networks from broadcasting their SSID. But this is absolutely a myth. Wouldn't it be interesting to find this? Before getting into action, one needs to carry out this preparatory phase for any wireless attack, which can be done using the wireless password cracking tool AirCrackNG on Pen Testing OS Backtrack or Kali Linux. This involves checking whether there exists a wireless interface up and running on the system. This can be carried out by opening the terminal and typing ifconfig. Once WLAN is found to be up, it is started using this command, which enables the current wireless interface, that is WLAN 0, in promiscuous mode, also called monitor mode, stated by Mon0 on channel 11. Normally, a wired or wireless interface works on a non-promiscuous mode, wherein the NIC accepts the data packets on verifying the frame headers only when it is addressed to the NIC's MAC, else it drops the packets. Enabling a wireless interface in promiscuous mode makes the interface to grab all the traffic irrespective of the frame headers. Now, in order to make the interface enumerate the traffic passing through the interface, this command is given. This monitors the traffic through the WLAN and enumerates the hotspots with their respective SSID and BSSID. One may find this hotspot whose SSID is hidden. Now press Ctrl+C to terminate further enumeration. With this, the preparatory phase is done. Let us get into launch of the attack for finding hidden hotspots, which can be done in just 2 steps. Step 1. Capture packets of the hidden AP. Step 2. Send deauth packets to reveal the hidden ESSID. Step 1. Capture packets of the hidden AP. To capture traffic of targeted AP, type in the following command. This starts capturing the traffic of the particular AP whose SSID is hidden on the interface Mon0 on channel 11. Step 2. Send deauth packets to reveal the hidden SSID. Sending deauthentication packets is carried out by opening another terminal and typing in this command. This command now sends deauthentication packets to the hotspot, claiming it to be sent by an associated client, which forces the access point, that is, hotspot, to reveal its SSID. Success! The SSID of this AP is found to be hacker. Thus we have proved that the agenda, "Don't broadcast your SSID," is a myth. Further, each and every Wi-Fi hotspot has a note below it. Some say WPA, some say WPA2, while this Wi-Fi hotspot says WEP. What are these? These are the wireless standards designed for the protection of wireless communication. Let us get an insight of what these standards are and how they work, to launch an attack to crack them. Starting with WEP. What is WEP? WEP stands for Wired Equivalent Privacy. This uses 2 modes of authentication, where the first one is the open authentication that requires no authentication, and the second one is the shared key authentication. The authentication in shared key WEP involves 4 steps. 1. The first step involves the client or station sending an authentication request for which 2. The AP sends a clear text challenge. 3. The client then uses the packet key to encrypt the clear text and send it back to the AP. What is this packet key? Packet key is equal to passphrase, that is WEP password X-OR-ED with state array that is nothing but random integers appended with initialization vector, wherein initialization vector is the checksum of the contents of the packet to be encrypted using CRC32. 4. The AP decrypts the clear text and checks for authentication. If the packet key is a valid one, then the connection is established between the AP and the client or station. Having known how WEP works, now let's get into cracking the WEP key for the network. This can be carried out in any of the four methods, namely packet injection, cafe latte, HERT, Corex chop chop. So it's time to get into action. Injection. Packet injection, also known as packet forging, is the process of interrupting a network connected by constructing packets that appear to be part of the normal communication. Having landed upon this web-enabled network in preparatory phase, let us perform a packet injection attack on this web-enabled network to crack its password. This can be done in just 3 steps. Step 1. Capture packets of the target AP. Step 2. Inject packets. Step 3. Crack the key. Step 1. Capture packets of the target AP. The command now captures and saves the packets in a file named hacker on the access point with this BSS ID and the channel on which it operates. WebKey can be cracked only if enough packets are captured, so the capturing is left to go on, while in another terminal, this command is given. This sends number of deauthentication packets specified by 10 to the AP from an associated client connected to this AP. Step 2. Inject packets. Now, in another terminal, type in this command. Here we start injecting ARP packets to the AP from an associated client in a new terminal, so that deauth packets are sent to the AP from the other terminal at the same time. This action of sending ARP packets will push the AP to reply back to ARP requests that will be genuine packets. Step 3. Crack the key. Now that the large number of packets transmitted between the AP and the client are captured in a file, this command. Upon specifying the length of the key as 64-bit for the target AP, opens up the saved file named hacker-01.cap via aircrackng and cracks the web key. Thus, web key is cracked using packet injection. Cafe latte. This attack allows obtaining a web key from a client system by capturing an ARP packet, manipulating it, and sending it back to the client, which subsequently generates packets that are captured and cracked to determine the web key using aircrackng. Having landed upon this web-enabled network in preparatory phase, a cafe latte attack can be done in 3 steps. 1. Launch of the attack. 2. Capture packets. 3. Crack key. 1. Launch of the attack. Having done with the prerequisites for launching the attack, let's get into launching one. The command when given, makes the attacker wait for a gratuitous ARP from any of the associated clients of the AP and grabs it to form ARP requests of its own and sets up a fake AP. Gratuitous ARP is a packet that is broadcasted by a client by setting the source and destination IP to itself and the dest port to this address, which is nothing but the broadcast port for resolving IP conflicts, updating ARP tables, etc. This GRAT ARP packet is captured to make one that will look like a legit one, and this is broadcasted to the network claiming the attacker to be the AP by changing its SSID to that of the legit AP. This will now dissociate the client from the legit AP and start associating the client to the fake one, thus making the client send back replies that would be encrypted with the legit key. 2. Capture packets. It's time now to capture the packets from the clients associated with fake AP to crack the password. Starting aerodump ng using this command, on WLAN 0, now we'll capture the packets and save it to the file named cafe. ARP requests from the fake AP now generates many genuine ARP replies from the clients that are captured in the file named cafe. 3. Crack key. Now that the large number of packets transmitted between the AP and the client are captured in a file, opening the same file with aircrack-ng allows cracking the WEP password. Aircrack-ng uses FMS and PTW attacks that are nothing but a form of cryptanalysis for attacking RC4 stream ciphers and do not need many IVs, that is, packets, to crack the key. The Cafe Latte attack allows cracking of wireless packets in an average time of 6 minutes, being the best case, while 2 hours to crack being the worst case. Hurt attack. This attack is an extension of the Cafe Latte attack, which sniffs an ARP packet and relocates the IP in the ARP header to convert the reassembled packet into an ARP request for the wireless client, for which it sends an ARP reply, thus allowing the attacker to collect new data packets encrypted with the WEP key, using which the attacker can crack the WEP password. Having landed upon this WEP-enabled network in the preparatory phase, Hurt attack involves 3 steps to crack the WEP key as that of the Cafe Latte attack. Step 1. Launch of the attack. Step 2. Capture packets. Step 3. Crack key. 1. Launch of the attack. This command waits for an IP packet or an ARP packet from any of the associated clients of the AP and grabs it to form packets of its own and sets up a fake AP. It then dissociates the clients and automatically associates the clients to the fake AP that has been set up. The variation between the Cafe Latte and this one is that the former waits till it captures a GRAT ARP, but here it is not the case. Whenever it finds a legit AP packet or an ARP packet, it is captured, manipulated, and resent to clients by setting up itself as the AP on christening itself with the SSID of the legit AP. This will now dissociate the client from the legit AP and start associating the client to the fake one, thus making the client send back replies that would be encrypted with the legit key. 2. Capture packets. Starting aerodump ng using this command, on the WLAN 0, now we'll capture the packets that is saved to the file named Hurt. 3. Crack key. Now that the large number of packets transmitted between the AP and the client are captured in a file, opening the same file with aircrack-ng allows cracking the WEP password. Aircrack-ng uses FMS and PTW attacks that are nothing but a form of cryptanalysis for attacking RC4 stream ciphers and do not need too much of IVs, that is packets, to crack the key. Thus, the WEP key is cracked using the Hurt method. Corix Chop-Chop attack. Corix Chop-Chop attack allows decrypting a WEP encrypted packet without the WEP key. It uses a brute force mechanism to achieve this. Having landed upon this WEP-enabled network in the preparatory phase, let us get into cracking the WEP key, which can be achieved in 4 steps. 1. Launch the attack. 2. Forge packets. 3. Start, capture, and inject forged packets. 4. Crack key. 1. Launch the attack. Now it's time to send fake authentication to associate the WLAN to the AP using this command. Which allows capturing packets to crack the WEP key. -1 here refers to fake authentication. 0 refers to reassociation time in seconds. -E refers to ESSID and -A MAC of AP, while -H refers to MAC of WLAN 0. Now it's time to launch ChopChop attack using this command. By specifying the MAC of the associated client and the BSS ID of the AP, we generate traffic and capture them as .cap and .xor file, which is then in the next step used to create an ARP request. What really happens when this step is performed? A web encrypted data packet is captured and saved as an X-OR file, and the traffic in the interface is captured as a .cap file after associating the WLAN to the AP by sending fake authentication packets. 2. Packet forge. Now it's time to carry out packet forging this command. The captured X-OR file manipulates another file named ARP request that can be used to inject the AP. The encrypted data captured in the previous step consists of the encrypted data along with the last 3 bytes ICV. The last bit of the encrypted data, that is the one preceding the ICV, is chopped down and a sequence of data ranging from 00 to FF is replaced at that point and made as a new data packet. This file, when injected to the AP, allows the ChopChop attack to guess the encrypted data. That is, it decrypts the data without knowing the key. 3. Capture and inject frames. Before injecting the ARP request generated, capturing and injecting of packets must be carried out by opening another terminal and giving the command, which saves the captured packets in a file named capture. The next step is to inject the AP with frames that have been manipulated and saved as ARP request file, which is achieved using this command. Once this file is injected to the AP, it starts broadcasting and the replies are captured by the attacker in the capture file. 4. Crack key. Now the time has come to crack the key. Now that many packets are transmitted between the AP and the client, and these are captured in a file, open the same file with aircrack-ng, which cracks the web password. Aircrack-ng uses FMS and PTW attacks that are nothing but a form of cryptanalysis for attacking the RC4 stream ciphers and do not need too much of IVs, that is packets, to crack the key. Here we open the capture file using this utility and the key is found here. ChopChop attack takes a longer time to crack the key since it uses multiple guesses when compared with the others. Thus, with this WEP, cracking comes to an end.
The next encryption mechanism incorporated by this hotspot is WPA. What is WPA and how is it different from WEP? WPA. WEP uses a 40-bit or 104-bit encryption key, which do not change and needs to be manually entered at the access point and clients. To overcome this weakness, WPA came into existence. WEP generates a per-packet key by concatenating the IV directly with the passphrase or master key, which exposes the master key to carry out attacks such as FMS and PTW attacks. WPA stands for Wi-Fi Protected Access, which works based on 2 mechanisms, namely PSK and TKIP. The PSK is a client authentication method wherein the network admin assigns a passphrase containing up to 133 characters. This passphrase is XOR-ed with keystream, which is a combination of a random 32-bit key, with IV, which is nothing but the checksum of 32-bit in length, to generate unique encryption keys. These encryption keys are constantly changed on a timely basis, which is then shared between the clients associated with the network. When a new client gets connected to the network, authentication request is sent to the access point, which in return sends a response asking for the password. A connection is established once the password is verified. PSK. Pre-shared key is simple and was designed for small offices and home networks that do not require an authentication server. However, The encryption keys tend to become old as time changes, since these keys are not generated dynamically upon login, and are subjected to brute force and dictionary attacks. This paves a way to opt in for the second authentication mechanism, TKIP. Temporal Key Integrity Protocol enhances WPA by increasing the length of IV by adding an extra 32 bits to the original 24-bit, accounting to 56 bits, to generate a unique encryption key for each client. However, only 48 bits are used in practice because 1 byte must be thrown away to avoid weak keys. Supposing, for the communication between two clients connected in a network, TKIP takes an extra precaution by ensuring that the data packet has not been altered or modified in any way by the attacker. If the data packet seems to be altered, it is dropped off. This is achieved by the 64-bit message integrity check, commonly known as the Michael algorithm. TKIP employs a per-packet key mechanism to dynamically generate a new 128-bit key for each incoming packet. This avoids the same keys staying in use as they do with WEP. TKIP also provides a rekeying mechanism in which it changes the encryption key of an ongoing communication in order to limit the amount of data encrypted with the same key. WPA cracking. This can be done in 3 steps: launch of the attack, generate traffic, and cracking the key. Before getting into action, one needs to carry out the preparatory phase for the attack, which involves checking of the wireless interface to be up, starting the wireless interface in promiscuous mode, and enabling the interface to capture the traffic on promiscuous mode. Once a WPA PSK encrypted hotspot is found, the capture is stopped and its details are jotted down. 1. Launch of the attack. Having done with the prerequisites for launching the attack, let's get into launching one. On selecting a particular connection that has WPA PSK encryption, let's get into capturing packets using this command. This command from the MAC address specified at --BSSID in channel 11 captures and writes it to a file name WPA crack with the extension IVS initialization vector, which is a readable file for aircrack-ng. 2. Generate traffic. Having now captured enough packets, the next step is to generate traffic. When this command is given, a number of deauth packets are sent to capture the WPA handshakes by specifying the BSSID of the wireless interface and the client to be deauthenticated. This is repeated a number of times to increase the capture of data packets. Once the number of captured packets exceeds 500, the next step is to crack the password. 3. Cracking the key. Now that many packets are transmitted between the AP and the client, and these are captured in a file, open the same file with aircrack-ng which cracks the WPA password. Apart from WEP and WPA, there exists yet another encryption standard, WPA2, adopted widely by many WLANs. But what is WPA2? WPA2 relies on TKIP, which works similar to that seen in WPA. WPA2 introduces CCMP, counter-cipher mode with blockchaining message authentication code protocol, a new AES-based encryption mode with strong security. It provides a stronger encryption when compared to TKIP. AES allows generating a 128-bit key, 192-bit key, or a 256-bit key for authentication. The plain text in a WPA-AES encryption undergoes 10 cycles of transposition, substitution, and mixing before getting XORed with the 128-bit key that is nothing but the passphrase XORed with the state array and appended with the 56-bit initialization vector. When the key size needs to be increased, the number of cycles of transposition, substitution, and mixing also increases, which helps in generating stronger
Having
got an insight about WPA2, on completing the preparatory phase for the attacks, this network seems to be using WPA2. Now let's get into cracking the key. WPA2 cracking. This can be done in 3 steps. 1. Launch of the attack. 2. Generate traffic. And 3. Cracking the key. 1. Launch of the attack. Once a connection is chosen, using this command, where aerodump-ng, which is a packet sniffer, is used to capture the packets from the MAC address specified at BSSID in channel 11 and write it to a file named WPA-crack with the extension IVS, which is a readable file for aircrack-ng. 2. Generate traffic. To increase traffic on the chosen AP, this command is repeatedly given in a new terminal. When this command gets executed, a number of deauth packets are sent to capture the WPA handshakes on the specified BSSID of the wireless interface and the client to be deauthenticated. Once the number of data capture packets exceeds 500, we may go for cracking the password. 3. Cracking the key. Now that a large number of packets transmitted between the AP and the client are captured in a file, opening the same file with aircrack-ng allows cracking the WPA2 password. This now allows the attacker to recover the key in an RC4 encrypted stream from a large number of messages in that stream. Thus, WPA2 cracking is done. Till now, we have seen how to crack the password for WEP, WPA, WPA2 enabled access points. Now, instead of cracking the password of an access point, let us try setting up a rogue access point that looks similar to the legitimate access point. Rogue AP attack. First of all, one should know what a rogue AP is. Rogue AP is a Wi-Fi access point that has been installed on a network and allows open communication without requiring a password, acting as a man in the middle between clients and the actual gateway. Another variant of this attack is an evil twin attack. An evil twin is a rogue wireless access point that disguises itself to be a legitimate AP, that is, a rogue AP is set up with that of the name of a legitimate AP. Here in this scenario, this system acts as the attacker machine in which the rogue AP is to be set up. Before getting into action the preparatory phase for the attack, which involves checking of the wireless interface to be up, starting the wireless interface in promiscuous mode, and enabling the interface to capture the traffic on promiscuous mode is done. Using the utility Airbase-ng, a soft AP, which is nothing but a rogue AP that acts as a legitimate AP, is set up using this command. The rogue AP is set up with a name similar to that of a legitimate AP, that is, Joker on channel 11, where we wait for a client to connect to this AP. With this, a rogue AP setup is done. But what is the use of just setting up a rogue AP? Usually a rogue AP is set up in order to perform a replay attack or an MITM attack. This now brings up the issue of making the victim connecting to this AP get access to internet. This can be achieved by opening another terminal and typing in this command. This command creates a bridge that unites the gateway to which the attacker's NIC is connected with that of a fake interface, which is created using this command. The interface AT0 is checked for its configuration using this command. This command is given to see whether the interface AT0 is configured and available in the interfaces list. Now that the interface we created is available, it is enabled to be up and running using this command. The interface is now up and running, but when a client connects to this AP, the interface must be able to assign an IP to the client, which can be achieved by this command. This now creates an assignable range of IPs starting from given value for the clients associating with the AP. Once this is done, finally the AP is enabled of port forwarding using this command. This will help the clients getting associated with this AP to access internet. Now when a legitimate client gets connected to this AP, one may find the MAC of the client being connected to this AP. By using this attack, one can use tools such as Cain and Abel or Wireshark to perform wireless sniffing or MITM attacks. Thus with this, we come to an end to wireless attacks, on getting a complete knowledge on network-based attacks. Having seen the ways in which these attack vectors harm a network, it should be noted that these actually disrupt the confidentiality and integrity of the CIA triad.